scientific notation. First, we need to know the definitions of both standard form and scientific notation. Standard form is when numbers that do not contain exponents are written, and these are the numbers that we normally think of. 200, 2,000, 9,900,000. Those are examples of numbers written in standard form. Scientific notation is when a number is expressed written as a product of a factor and a power of 10. Now what that means is you take a number such as n, you multiply it by 10 to the x power. Now when we're going from scientific notation to standard form, like in these examples, we would have 2 times 10 to the third power. That is scientific notation, and we want to change it to standard form. So our rules for this are going to be when it's positive, we're going to move right, and that's only when we're going from scientific notation to standard notation. So first, we identify where the decimal is within the problem. If we have a whole number such as 2, then the decimal is going to fall right after that number. So it would be 2 and then the decimal. And it tells us in the problem that it's to the third power. So 10 is to the third power, meaning that we're going to move our decimal 3 places to the right. Now when we do that, we end up with 2,000 because we have 3 places that we have to put something in, and what we do is we put a 0 in that place, so it becomes 2,000. Now an example where we have a number like 2.1 that has a decimal within the number that we're given, it's 2.1 times 10 to the third power. Now we place the decimal, which is already given to us, and we move it 3 places to the right. Now when we do that, it gives us 2,100. Notice how the 1 stayed within the problem as well, and instead of adding an extra 0 like we did in the first problem, we're going to leave that 1 there because that's the value that we're given. Now, if we have a negative exponent in the situation, that negative exponent is telling us to move left. Again, this is only when we're going from scientific notation to standard form. Now, we're given 6 times 10 to the negative fourth, and we're moving, remember, left because that negative 4 tells us that we're moving left. Now we have to place the decimal. So looking at the example 6.2 times 10 to the negative fourth, we identify that the negative 4 is telling us that we need to move to the left. So we identify where the decimal is currently at. It's between the 6 and the 2, and we move it 4 places to the left. That gives us 0.00062. Now, if we're doing the opposite, going from standard notation to scientific, like 4 million to 4 times 10 to the 6th power, or 0.0003 to 3 times 10 to the negative 4th power, there's some different rules that apply. We reverse the rules that we just learned, and if you're moving to the left, it becomes positive exponent, and if you're moving to the right, it becomes a negative exponent. So if you're given the number 320, we identify where the decimal is, which is usually at the very end if it is a whole number. So it is after the 0 and the number 320, and we have to move it until we get a number that is between 1 and 10. So in this situation, we would move it 2 places to the left. That would make it 3.2 times 10 to the 2nd power. Because it's positive, we would make the exponent positive because it is greater than 1. Now if the number is less than 1, then the answer for the exponent becomes a negative. So we need to keep in mind, though, that it's always going to be less than 10. So we don't want this to be 32 times 10 to the something power. We want it to be 3.2. Another example is if we're given 602,000, The decimal is at the end after the final 0. We move it to the left until we get to just a single digit in front of the decimal. In this case, it's going to be 6.02 times 10 to the, and we count how many spaces we moved. So 1, 2, 3, 4, 5. So it becomes 6.02 times 10 to the 5th power. Notice how nothing was left off. The only thing that is taken off is the zeros. Any number is left there. Now, in this particular problem, we are given 602,000. So the 0 in between the 6 and the 2 is significant. And because it's significant, we leave it there. We always have to have a number that is between 1 and 10. So in this case, instead of writing 602, we would write 6.02. Now, examples where we would have negative exponents. You're given the problem, 0.000071. Well, again, it always has to be between 1 and 10. So because of that, we're going to move the decimal between the 7 and the 1, because the 7 is going to be between 1 and 10. And the 1 is still going to be included because it is a significant digit. Now, how many places do we have to move to the right to get there? We count that, and it's 6. But because the number was less than 1, we have to move it to the right, and that makes it negative as the exponent. So the answer becomes 7.1 times 10 to the negative 6th power. Now, looking at another example, 0.034. We again identify where the decimal is and where we want it to go. So if we want it to go between the 3 and the 4 to make the number between 1 and 10, we would move the decimal 2 places. So we end up with 3.4 times 10 to the negative 2 power. Again, it's negative because we're moving to the right and the number is less than 1 to start out with. So anytime the number is less than 1, we know we're going to be moving to the right, and it creates a negative exponent. Anytime the number starts out greater than 1, we know we'll be moving to the left, and it will create a positive exponent.